Good day. The topic we are treating today is statistics. This video is a continuation of what we've been doing, but here we talk about measure of location. In measure of location, we talk about how to obtain the mean, median, mode, quartiles, percentiles, and deciles of grouped and ungrouped data. In the former videos, we already talked about what grouped and ungrouped data is and how we can group data into class intervals. So the lesson objectives is for you to know how to obtain the mean, median, mode of group and ungrouped data, and also to know how to obtain the quartiles, percentiles, and deciles of grouped and ungrouped data. So that by the end of this lesson, you will be able to obtain the mean, median, mode, deciles, quartiles, and percentiles of grouped and ungrouped data. So the topics the viewer of this video must have been familiar with before you can watch and understand this video is tabular representation of data, that is for both grouped and ungrouped data. You should know how to construct a frequency table, a cumulative frequency table, and also you must know about approximation of numbers, how we approximate numbers. So now we move to measure of location. As a measure of location is also referred to as measure of central tendency, and there are many types of this. We have the most popular type, which is the arithmetic mean. So we also have the median, which is also known as the middle number, the mode, that is the number of time a particular data occurred, the one that has the highest occurrence, the quartiles, that is the deciles. Deciles is all about 10 as it implies deci, and percentiles hundreds. So others are the geometric and harmonic means. So here we talk basically on mean, median, mode, quartiles, deciles, and percentiles. So now we start with the first one, which is the arithmetic mean. So the arithmetic mean, here we talked about the arithmetic mean of ungrouped and grouped data, and we also explained some examples on it. So the said arithmetic mean is the most important measure of location. So the most important aspect of measure of location is arithmetic mean. So it is the sum of all the items in a set of data divided by the number of items in the set of data. So if you have 6 items, you add the 6 items together, then you divide it by 6. Since 6 is the number of items in that set of data given. So arithmetic mean can be calculated for grouped and ungrouped data. So we take it one after the other. We calculate for ungrouped data first, and we solve examples on it. Then we go for grouped data. You all know what grouped data means. That is when we have class intervals. So we see the difference between calculation of arithmetic mean for ungrouped data and that of grouped data. So now we move to the first one, our mean of ungrouped data. So assuming you are given a set of items, these are the set of items. We have the first item noted as S1 here, the second item, the third item, up to the last item, say it's noted by nth item. So now we know that the total number of items here is n. If you start counting 1, 2, 3, 4 up to n. So now we can obtain the arithmetic mean noted by x bar. This is x, this is the bar. So this is the symbol for mean. Whenever I see something like this, you know they are talking about the arithmetic mean of a set of items. So here S bar is the symbol for arithmetic mean. So from the definition we read earlier, they said it is the sum of all the items in a set of data divided by the number of items in that set of data. So this is the set of items given. So you add all this to their selves. That is, for by definition, you add a set of items divided by its number, which is n, and that is what we have here. So this numerator can be written in a simpler form using the summation symbol. This symbol means adding up. So you can write this in a simpler form by saying summation, the starting point of this is 1. You can say that 1 is the starting point and the stopping point is n. And that is how to write things in a simpler form using this kind of notation. We have the summation symbol, we have the product symbol, and so on. So you can write this as xi. So whenever you take each value of I and increasing it by 1 every time, this summation means you'll be adding them to one another. So if you want to open this, you first start with, I is starting from 1, you have S1. This symbol means plus, you write plus. So if you add 1 to 1, you have 2 plus S2, which is what we have here, and so on till you get to the stopping point, which is n. So divided by this n. So this can be written in a simpler form as this. So this symbol means adding up, as I've explained. So that's adding up the set, this, which is set of items given, and the divisor, which is the total number of items, is n. So there are some times when the number of items is large, that is, we will not have small numbers like this. x1 can repeat itself many times, s2 can repeat itself many times, s3 can repeat itself many times, and that is when we have to construct a frequency table. In that frequency table, we have 3 columns. First one is the item column. S1 will have occurred several times, maybe like 4 times. So item column, frequency column, as we've discussed in tabular representation of data, frequency is the number of time an item occurs or shows up. So assuming S1 shows up thrice, we have x1 plus x1 plus x1, which is 3x1, which is the same thing as saying 3 multiplied by x1, which is also 3x1. So that is why we have the frequency. So for you to get the total number of items in that set of data, you have to multiply the item by the frequency for you to know, if you have x1 thrice, for you to know the total number of x1, to calculate all the numbers in that set of data, you have to multiply x1 by its frequency, which will now give you 3x1. So you can calculate like that. So that is why we have the third column, which is the column for the product of the item and its frequency, for you to know the total number of items in that set of data. Instead of you to be adding like 50 items together, you can just use this in a simpler form. So for you to know the total number of items, instead of you to be counting 1, 2, 3, 4, so you can just add up the frequencies of the items, the number of times they occur. If x1 occurred thrice, you know that 3 times, you write 3 for x1, and 3 multiplied by x1 will give you the value for the column for the product of item and frequency, to know the summation of all the items. So now here the formula for mean will change. You first have to add all the column for the product of item and its frequency. So this is the frequency of x1, which is the first item, multiplied by x1, plus the frequency of x2 multiplied by x2 up to the last item, which is frequency of xn multiplied by xn, divided by the sum of all the frequencies of the item, which I have explained earlier. So this can also be written in a simpler form like we did for the first formula, which now is summation I equals 1 to n f of xi multiplied by xi, and that is what we have here. We just choose one of these and we represent this by I. We know that the starting point is 1 and the stopping point is n, divided by this one. We also choose one of this, summation I equals 1 to n f of xi. I will start from 1 to increase by 1 every time till you get to the stopping point, which is n. Assuming n is 6 here, we have f of x1 plus, which is meaning of this symbol. If you add 1 to 1, you have 2 f of x2 plus f of x3 plus f of x4 plus f of x5 plus f of x6, which is the stopping term since we said our n is 6. And so this formula is for calculating mean when the data is large, that is when you have 3 columns, that is the item column, the frequency column, and to get the total number, you get the summation of all the items in that set of data. You have to have the column for the product of the item and its frequency. So you use this formula to calculate the mean. But the moment you see that the number is not very large, that is if you have like 3, 4, 5, 6, 7, 8, 9, 10 numbers to like 10 numbers, then you can use this first formula. But the moment you have 50 numbers, 100 numbers, you can use the second formula. So this is tagged as 1 because we may make reference to it in some other places. So the formula for obtaining the mean is given by 1, which I've explained, and I've also explained this. This is the frequency of each item in the set of data. So now we solve examples. So the first example says we should find the arithmetic mean of this numbers. It's not much, so we can use the first formula. So the formula for obtaining the mean is this, and since we have 6 numbers, if we should expand this as I've explained earlier, we have x1 plus x2 plus x3 plus x4 up to xn, but here we can see that our n is 6, so we just have x1 plus x2 plus x3 plus x4 plus x5 plus x6. So now our x1 is 42 plus 56 plus 38 plus 41 plus 86 plus 56 divided by the total number of items, which is 1, 2, 3, 4, 5, 6, and that is why we have 6 here. So we should add this up. We have 319 divided by 6. So 319 divided by 6 will give us this. We are very conversant with how to approximate numbers. Here I said I approximated this to 2 decimal places. That is, we will stop the approximation at the second number after the decimal point, and that is why we have 51.17. So that is that. So we now talk, the second example will show us when we have a very large data. Here we are talking about marks scored by 50 students. So to start adding things from 1 to 50, here you can see adding 50 numbers in all will take a very lengthy time. So that is why we have to encompass that in the frequency table. So they said the following marks are the marks scored by 50 students in an examination. So these are the marks. So we first look for the numbers that are in that scores. Numbers, there are some numbers that will repeat itself. So we look for the main numbers, and then we now count the frequency, that is the number of times they occur. So here we can see 12, we can see 15, we can see 20, we can see 25, we can see 30. 20 is repeating itself here, 30 is also repeating itself, 15, we already see it, 12. So you just pick one of the numbers, one of the scores, for it to put them in the item column. So we don't have any other number aside 20, 15, 25, 20, and 30. So that is all in your item column. You can see xi, item column. So now we now go back to the scores and check the number of times they occur. So now number of times 12 occurs. We start from the beginning. 1, 2, that's how you count. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can see that 12 occurs 16 times. So that is the frequency of 12. Then we also count the number of times 15 occurs, which is 13. You go back to the data and count. The number of times 20 occurs is 9. The number of times 25 occurs is 5. And the number of times 30 occurs is 7. So if you should add up all this frequency, you must get the total number of marks they said people had in the examination, which is 50. So let's check if that is true. And that is the total number of items we have in that set of data. So 16 plus 13 is 29, plus 9, 38, 38 plus 5 plus 3, and plus 3 plus 7 is 50. You can see that this frequency, the addition of the frequencies gives the total number of items in that set of data. So now we want to see the summation of all the items in that set of data. So if you should start summing this one after the other, these numbers, these scores one after the other, it must be equals to when you multiply this set of items by their frequencies and adding it up. So 12 multiplied by 16 will give 192, 15 multiplied by 13 will give 195, 20 multiplied by 9 will give 180, 25 multiplied by 5 will give 125, and 30 multiplied by 7 will give 210. So if this is added together, we have 902, which is equal to adding each numbers in the set of data to one another. So now here we use the formula given for mean. Now this is what we have for the mean, and this is the sum of all the columns of multiplying the frequency by set of item. And you know that for that we got 902, and the addition of all the frequencies is 50. So 902 divided by 50 we give 18.04. So rounding this off to the nearest whole number, if you really know about approximation, we have 18. So the mean score is 18. So if you round it up to the nearest whole number, the mean score will give 18. So that is that about mean of ungrouped data. So now we move to mean of grouped data. So the only difference between the mean of group data and mean of ungrouped data is that you have a class interval here in mean of group data. So here we have the column item. We'll pick it from the marks in the set of data. But here for you to know your column item, you have to obtain your class mark. Your class mark will represent the column item, and you know how to obtain the class mark if you've watched the previous videos on statistics. To obtain the class mark, you add the lower class limit to the upper class limit and you divide by 2. So here the class mark of each class interval will represent the column item, which are the xi's as we have discussed earlier. So here we also construct a frequency table, but that frequency table will consist of 4 columns. The first one is the class interval column, which you all know how to obtain. You know how to obtain the class interval. To obtain the class interval of a group of data, you first obtain the range, that is the highest data minus the lowest data, and then to find the class width, that is the number of items that will be contained in a particular class interval, you divide the range by the number of intervals you want to have. So also we have the frequency column and also the column for the product of item and its frequency. You know why we have this, as I've explained earlier. So and also we use the formula 1, that is summation I equals 1 to n f of xi multiplied by xi divided by summation I starting from 1 to n f of xi. So also we move to examples. Here you can see that we are given a set of data and we have so many numbers included in this. We have several numbers, we have 17, we have very big numbers. So we have to calculate the mean mark of this distribution with the frequency table consisting of 8 intervals. So this question says they want 8 intervals. So now the first thing you do is to obtain the class width, then you obtain the intervals and then look for the frequency of each intervals and the class mark, then you find its mean. So the first thing is to obtain the class width. So the first, as I've explained earlier, we find the range. The range is the highest mark minus lowest mark. So you check the set of data given. What is the highest mark? Can see for this 82 is the highest here. So let's see if there's any other number greater than 82. Let's check. You can see that 82 is the greatest mark, and the lowest mark here is here we have 15, we have 13, 13 is less than 15, we have 12 is less than 13, so here is 12. Let's check if there's any other number lower than 12. You can see that 12 is the lowest number, so minus 12 is 70. So class width will be range divided by number of intervals. You know, from the question they said 8 intervals in all, so it's going to be 70 divided by 8. 70 divided by 8 will give 8.75, and if that is approximated to the nearest whole number, we have 9. So from this lowest number, we count 9 number, including the lowest number. That to be the upper class limit of the first class interval. Right, so let's start from 12, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is how we have 20 here. Then we start from 21 again. We count 9 numbers starting from 21. We have 29. Then after 29, 30. Count 9 numbers starting from 30, 38, up to the 8th interval, which is 75 to 83. We can see that this 83 is greater than the highest number we have in the set of data, but it also encloses the highest number we have. So now we construct a frequency table. You already know how to construct a frequency table of the 4 columns we discussed earlier, which is the column for class interval, the column for the item. You know, we already said the class mark will represent the item, the frequency, the number of time the marks in this range, in each range of the class interval occurs, and then the column of product of the frequency and the item. So the summation of this will give the addition of all the numbers in that set of data, and summation of this will give the total number of items in that set of data. So now here we calculate the class mark for this, and to calculate the class mark, we had the lower class limit to the upper class limit and divide by 2. So 12 plus 20 is 32. 32 divided by 2 will give 16. So 21 plus 29 is 50. 50 divided by 2 will give 25. Do the same thing for all other class intervals. So we have 16, 25, 34, 43, 52, 61, 70, and 79. So these will represent these items. The class mark here will represent the items. So now look for the frequency, the number of times the marks within this range occurs, which is 12, 13, 14, up to 20. So we go to the set of data and then check the number. So this is within the range 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12. We counted 12. So that is 12. So we do the same thing for all other class intervals. We do for 21 to 29. So we have 21, 22, 23, 24, 25, 26, 27, 28, 29. Count number of times the mark within this range occurs. So if you should count, you have to say it 11 times. Here for this class interval is 8 times, and so you do the same thing for other class intervals too. So this is it. You can check if it is correct. So the next thing you do is to multiply the class mark, that is the items, by its frequency. So 16 multiplied by 12 will give 192. 25 by 11 will give 275. 34 multiplied by 8 will give 272. 43 multiplied by 8 will give 344. 52 multiplied by 4 will give 208. 61 multiplied by 4 will give 244. 70 multiplied by 1 is 17, and 79 multiplied by 2 is 158. So you add all this together. Then you have the criteria to obtain the mean now. So now this is the formula for the mean. So this is the formula for the mean. So now this is summation of the product of frequency and its item, which is given as 1763 from here. If you sum all this together, we have 1763 and the total number of items is 50, which will now be 1263 by 50. If that is done, we have 35.26. So therefore, the mean mark of the mark distribution is 35.26. That is how to obtain the mean of data. This will be the end of this video. The next video will be more on statistics, measure of location, that is other measure of location, which is median, mode, percentile, deciles, and quartiles. Next video will be more on statistics, measure of location with sample questions and solution. Please subscribe to our YouTube channel, like and share our videos. Thank you.